Hey guys, I'm Abdullah from ARD's department. Today we're going to see about hidden markov model. So what is hidden markov model? It's a statistical model that helps us to make predictions about the things that we can't directly observe. Based on things we can observe, so it is mainly what it is. If we can't go out and saw the weather, if we saw suddenly someone taking the umbrella and going out, then we can predict that it might be rainy or too sunny. So that is what hidden marker model. And the objective. The objective of the program that we're gonna do is to calculate the total probability of observing a given sequence of observation based on HHA and to estimate the most likely state at each step using forward probabilities. And the first step of the program is to import the required library. It is more important for doing any Python program. So as far of now, we're gonna read only NumPy because we deal with probabilities, calculations, so and matrix operations. So for that, NumPy is far enough. So next step is transition probability matrix. As for hidden macro model, we are required to have three parts. The first one is transition table, emission table, and initial probabilities. So first we're going to declare transition table. So this matrix tells us about how weather changes from one day to the next day. And next one is emission probability. So this tells us the chance of seeing an observation from the given weather. And next one, initial probability. It is more important. Without initial probability, we can't calculate any problem solution. And the initial probability of rainy is zero point 0.5 and initial probability of sunny is zero point 0.5. Next one is defined observed sequence. So observed sequence are observations that we took for the over 6 days or 7 days up to n number of days. And one denotes walk and zero denotes claim. And alpha table. So we're going to create an alpha table using forward probabilities, which requires two for loops. So we're going to create an alpha variable and store a value of np dot zeros of n of observable sequence comma initial probabilities. Observable sequence is 6, initial probability is 2. And next one is initialization of alpha table. So we're going to start the alpha table initialization by multiplying the initial probability of being in a state into the chance of seeing that first observation from that state. Next, adding all the values in the alpha table using the recursive forward algorithm. We are going to use two for loops where t indicates the time and j indicates the state, and t's range is 1 comma observable sequence and j's range is only the initial probability 2. And we're going to store the alpha table by multiplying all the possible previous states into transitioning to the state j into emitting the current observation from state j. Next one is total probability of the sequence. We're going to calculate the total probability of sequence by using np dot sum of alpha's first range of values up to the last range of values. And we're going to get the final probabilities. And the last step is to estimate most likely state sequence. For that, we use for loop with a range of observable sequence where if alpha of t comma 0 is greater than alpha of t comma 1, we absolutely know that it's sunny, and else most likely to happen is rainy. So we're going to see the output at large. The output of the probability of observed sequence is 0.01573, and the most likely states are sunny, 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 rainy, rainy, and sunny. This is all about hidden macro model. Thank you guys.